So a complete structural formula is, for all intents and purposes, a Lewis formula, at least the ones we do in this class. Butane has 1, 2, 3, 4 carbons, and the A and E ending, but means the 4 carbons. The A and E ending means I have all single bonds here. Did you raise your hand for something?
Look, I copied the notes, and it says below as an example of complete structural formula for butane, and it just has 3 carbons.
Oh, okay. This should be propane here. Sorry. So look at your notes.
I messed up like 4 my head.
Well,
Wait, didn't you say put the complete structural formula of butane on the quiz?
is that what it said?
Yeah.
Okay.
Well, we copied it from that.
Okay. Now you know it's propane.
Yeah, but we missed the
Yes, I understand. Now you know it's propane.
So, are you not going to cut off for that or something?
I'll give you an opportunity to make it up.
I got it right. I got it right.
You just told us it was butane.
I got it right.
That's what you said in the notes, so we thought it was butane.
Okay, change your notes now, and let's move on, okay? Nobody should be worried about it, okay? All right. So then, a complete structural formula for pentane would have how many carbons singly bonded together?
What?
5. The end carbons have to have 3 hydrogens because they need 4 bonds.
Oh, I got it right.
The ones in the middle need to have 2 hydrogens.
So what would be the formula for that one of the middle C's?
CH2 for a condensed structural formula. Is that what you're asking?
Yeah. Why would it be C? Because you got 2 carbons bonded.
I'll show you. I'm going to do that next, okay? All right, so to condense it, then what we do is we take each of these carbon groupings and write it like a separate formula. Okay? Remember, pent means 5, A and E means all single bonds. Okay?
So you only count the ones that's bonded to carbon and hydrogen, not the carbon to carbon?
No, you're right. Yeah, that's correct. Okay? So a condensed structural formula then we'll take each of these carbon groupings and make that a sort of a separate formula. So I've got carbon and 3 hydrogens here, so we'll call that CH3. Okay? Right. CH2, CH2, 1, 2, 3 of these. No, 4 of these. Wait, 1, 2, 3, 3 of these. And then the end one has CH3. Okay? So this is a condensed structural formula for pentane. Now this is the form that I require of you in this class, okay? If I ask for a condensed structural formula for something, this is the form you're supposed to use.
Does that say U?
Okay? I'm going to show you an even more condensed formula, but you can't use it in this class. I'm only showing it to you because if you ever see it somewhere written down for you, you'll know what it means. Okay? So, well, don't write it down then, okay? But some of you may see this from time to time, okay? I'm thinking of Ryan back there because he's a firefighter, might see this sometimes, okay? So what you do there is CH3 will be written just the way it is here, but we're going to take 1, 2, 3 of these groups, CH2 groups, and sort of combine them, yeah. So that is another way of writing it, but you can't use it in this class. I'm just showing you that it means the same thing.
Why can't we write it?
Because I told you you can't.
That's it.
All right. Then there's a way of condensing this even further. Okay? And that's called a skeletal formula. And a skeletal formula only shows the bonds between atoms except for the bonds to hydrogen atoms.
Only shows the bond.
Yep. Mm-hmm. All right. So how many bonds are there? Look up here at pentane and count the number of bonds that exist between all atoms except for those bonds to hydrogen. How many bonds are there? Okay, he says 4. Does anybody disagree? Do it for yourself and figure it out for yourself. No, just the bonds between atoms except for those bonds to hydrogen. How many bonds are there except for the bonds to hydrogen? 4 bonds. There's 1 here, 1 here, 1 here, and 1 here. That's 4 bonds, right? So all we're going to do is draw those bonds. 1, 2, 3. Wait, that's not right. 4. I miscounted my lines here. Okay. So 1, 2, 3, 4 would be that, right? No. 1, 2, 3. No, I'm sorry. That is right. 1, 2. 1, 2, 3, 4. Okay. 1, 2, 3. 1, 2, 3. No. 1, 2, 3, 4. There we go. Golly. Or 1, 2, 3, 4. Or 1, 2, 3, 4.
You can't make a box.
No, that'd be something different. Just about.
1, 2, 3, 4.
Okay? All of those represent pentane and a skeletal formula. Okay? That's just showing the bonds between any atoms except for those bonds to hydrogen.
So that means propane would have 3. Yeah.
Yes. Wait a minute. Propane will have 2 lines, 3 carbons. Just 2 lines. Mm-hmm. Okay. All right. Quiz yourself. Write all 3 structural formulas and all of these are structural formulas. You got a complete structural formula, condensed, skeletal. Write all 3 structural formulas for heptane.